Hello guys, welcome to In 5 Minutes. Let's try to understand what you mean by deadlock detection or the term detection. Detection simply means to detect something going wrong. Consider human side of it. You're not feeling well. Is it something wrong with you? That's why you're not feeling well. So detect what is wrong. Is it just mood or is it some physical? When you check yourself, you would soon understand that you are sick, which is a bad thing. But when you know that you are sick, you can take preventive actions. You can know to handle sickness which medicine is needed. Same way, here we are trying to detect that something wrong with the system. If system has something wrong that would be detected, maybe that can be a deadlock. For that we need to detect. By detect we need two things. Yes or no. That means whether deadlock exists or not. If so, where? So that we can solve it. And solution to that would be a recovery, which would be the next part. Currently, let's try to concentrate on detection. So let's start deadlock detection. Deadlock detection is possible via three basic means: resource allocation graph, hierarchical system, and fully distributed. In each of them, we are trying to achieve basic things as number one, detect deadlock. There or not. If detected that deadlock exists, then where deadlock is, and later after detection, there would be the next step which will recover from it. So let's go with each technique in detail how they work. In resource allocation graph, we'll graphically present the current situation of the system. This will work in two phases. We'll first make resource allocation graph, and once that is made, we will convert it for, or rather convert it in wait for graph, and if in wait for graph we find cycle, then that cycle may lead to deadlock. This is a basic scenario in which we are trying to work. Let's try to understand certain representation. In resource allocation graph, we represent resources as a rectangular box, and depending on number of instance a resource has, this small square box would be given. Process is represented with a circle. If we say process 1 has instance of resource X, it can be represented in this manner. You can say it this way. Be careful as the arrow is coming from inside and going to process. On the other hand, if we have to say P1 wants instance of resource X, then in this case P1 arrow would start from P1 and stop at the boundary of Rx. So be very careful. I'm saying again one more time. If P1 has an instance of Rx, the arrow would start from inside and will point to P1. If P1 wants instance of Rx, then arrow would start from P1 and would stop at the boundary of resource X. So be careful. Let's try to go further.